welcome. Thanks a lot for your time today, for joining us in our Reboot Aviation webinar, The Future of Winter Operations and How Technology Can Improve Operational Readiness. With me today here in this webinar is Robin Riedel, partner at McKinsey and Company from the US. My colleague Christiaan, Chief Customer Officer from Assaia, and Vincent Lambercy, the founder of FoxATM. A little bit of housekeeping before we start. Today we do have a hard stop after 1 hour. Please ask questions. We definitely will answer all of them. If we cannot answer them during the webinar, we will come back to you and answer them specifically via email. So no matter how long it takes, please ask questions. There will be a poll towards the end of the webinar. Would be great to get your feedback in order to also give us the chance to improve for the future webinars. All right. This webinar will be recorded, so you will find the recording later on YouTube. And in case you want to see some of the topics again that are discussed today. What's the agenda? We will start with an introduction, setting the scene, introducing the speakers. Then Robin will take over and present his bit, give a little bit of a high-level overview of what the situation is, what the issues are, but also what kind of general solutions there are. Then I think there is a mix-up. Then there will be Vincent from FoxATM giving an in-depth analysis of what the intricacies of winter operations are, what are the problems, what we have to take care of and to watch out for. And then in the end, my colleague Chris will provide some of the solutions that are out there that can help and mitigate the problems of winter operations and also help to mitigate the impact that winter operations have on the airport general operations. So what is the bigger picture if we look at, okay, we are now in a wider airport environment. So today, the topic today about winter operations primarily affects the airspace and on the airside level, outside of the terminal, ground handling operations, and so on, and also a little bit the airport operations control center. And without any further ado, I will hand over to our panelists today, Robin Riedel, Christiaan, and Vincent, to briefly introduce themselves. So Robin, please go ahead.
Yeah, thank you so much for having me and for organizing this. So look, I'm a partner at McKinsey. I do a lot of work within the aviation value chain and have a somewhat personal relationship to winter operations, both because I'm an Airbus pilot and I've spent many hours sitting in line waiting for de-icing. And I also used to lead some of our ground product at Air Canada many years ago, and being in the Great White North, had quite some experience with winter operations there. So very glad to be here today.
Hi everyone, my name is Christiaan. As mentioned, Chief Customer Officer at Assaia, which means that I work mainly with our existing customers, airports, airlines, and ground handlers to make sure they get the maximum value from the products and services that we provide. And I'll be drawing on some of my past experience in winter operations from my days at Amsterdam Airport Schiphol as well. But I'll elaborate on that further on in the presentation. Thanks.
Hi, Vincent Lambercy from FoxATM here. Thank you for having me. I've been in ATC and ATM for the best of the last 20 years, working with ANSPs, and for 3 years now doing consulting on ATC and airports.
All right, thanks a lot. Then I would say, Robin, the floor is yours.
Great, well, thank you. Well, let's jump right into it. So I think intuitively many of us know that winter operations provides a significant challenge for airlines. Just to name a couple of facts here to just show the extent of how big it is. So the runway capacity in most airports in winter conditions, so meaning either drifting snow or some snow on the ground, etc., goes down by as much as half. And knowing of how busy airports were prior to COVID-19 and hopefully again soon, you can see how that is a significant challenge. Looking at delays, about 4 times the delays happen in winter months than they would in summer months. That's just the straight numbers. And so the impact of winter on just on-time performance and reliability is clear. In a single airport like Chicago, you're going to talk about over thousands or so flights being impacted, either canceled or, in this case, canceled or delayed further by a big weather system. So when a storm front comes through, it can completely ground the system, in whole regions. And then lastly, just on de-icing alone, not even considering any of the delays or impacts of dislocation and reprotection, you're talking over $1 billion a year spent in an industry that, in a good year makes $30 billion in profit, right, globally. And so these numbers are significant and meaningful. And so winter operation is a big cost driver and a big driver of passenger dissatisfaction and a big driver of inefficiencies. And so it's something where I think airlines are keen to drive further efficiencies, and technology might provide some of those. Let's jump to the next slide here to make this a little bit concrete. We all think of winter as a romantic, winter wonderland. The snow comes down and, it feels nice and cozy in front of the fireplace. But I can tell you, when you're in the airline operation, that feeling, drifts away pretty quickly, and you start getting to terms with the reality of winter operations. So let's go one further slide to see what kind of the challenges are here. So what you'll see here is a number of issues called out that are caused by winter operations, right? Poor visibility, snow or ice on the ground, snow or ice accumulating on aircraft wings, or even just the temperature and the risk of ice creates a number of new processes, right? So for one, you have to inspect the aircraft before you taxi out. You have to keep the gate areas clean and free of ice for personal safety of the people working there, but also for the aircraft. As you kind of taxi to the runway, you might have to de-ice the aircraft or even anti-ice it. And so applying a liquid, usually an alcohol-based liquid, that will take off the ice or snow on the wings and on the fuselage and prevent, for the next couple of minutes or hours, additional ice or snow sticking to it. And so it creates an additional process in de-icing, as you see at the bottom right here. And there's a number of issues that come with that. It's hard to really get the sequencing right, to have aircraft line up for de-icing, be ready for de-icing, come out of de-icing. And so there's going to be wait times. We're spraying a lot of de-icing fluid, and generally speaking, it's humans that apply it out of a bucket on top of a crane on top of a car, and so the precision of the application is not very high, and as a result, we overspray and we waste quite a bit of fluid. Some of that gets recaptured, but still. And then it's hard to assess the conditions afterwards. As a pilot, how do you know for sure that your fuselage and your wings have been de-iced after de-icing? You have someone on the outside telling you that they did. Maybe you walk backwards, look out the windows, and sometimes you see when the pilots come back after de-icing, that's what they do. They look out the windows to look at the wings to see if they're clear. But it's a pretty archaic way of doing it. And then, you get to the runway, you're not quite sure, how bad the snow is around you. And so you're not quite sure how long the wings will stay free. So there's a lot of safety buffer built into those times. And that's just the aircraft flow. And then on top of that, you have to actually keep the surfaces clear. So you need labor and equipment, snow plows, but you only need them some days in the year. And so how do you best staff for that? So as you can see, there's a lot of uncertainty in the process. So that's where we get excited about technology. So if we go to the next slide, please. Let's imagine for a moment we were in the year 2025 or 2030, and what would this look like if we really leverage technology into winter operations? We'd have granular real-time situational awareness of conditions. So we would know in real time, what do the different aircraft surfaces look like? How much snow or ice is on them? How much is coming down? How much is the temperature? We would know the same for aircraft in a more sophisticated way than a pilot looking out of the window. We would have advanced weather forecasting systems that also go very granular, so we can directly integrate that into the airport planning. So we know much more granular than today when the snow and ice will come in, when the temperatures will be in critical conditions, and so can plan for it much better and adjust in real time. We would have optimized precision application of interventions. So interventions being either spraying or even snow removal, but just being much more precise in the way we use de-icing fluids, in the way we use snow plows, in the way we we use holdover times, etc. Would be kind of the next step there. Real-time coordination across a range of stakeholders and processes. Excuse me. Making sure that everyone who's involved in the process has the same information and operates in the same level of planning, right? So do you have the ground handlers who might do the de-icing spraying, you have the airport who coordinates taxiways and snow removal, you have ATC who controls parts of the departure, and a whole bunch of other stakeholders like the airlines, etc. And so making sure that they all work together on the same information in a coordinated way. Optimize buffer placement to minimize waste. So in aviation, we place a lot of buffers for safety and for reliability. And, some of those buffers we set up 20, 30, 50 years ago when we didn't have a lot of good information and a lot of, call it advanced analytics. And so maybe it's time to reduce some of those. And if we could be more precise in knowing what we do and use more input, we could be reducing some of those buffers. And then lastly, automating some of the manual processes to help with some of the labor issues that winter operation brings, both from a safety perspective, not have people slip, but also from a unpredictability of when you need the labor and how do you keep it for some of these events. So that would kind of be the dream world. A couple of ways we're going to get there, which is mostly around technology here. So we group this into 4 opportunity themes. There's a theme around improving forecasts, right? So if we use micro weather forecasts, if we use taxi and de-icing time forecasts that are a bit more, call it advanced than many of the deterministic just lookup tables we have today. Have a broad network of IoT sensors, ways to assess the current conditions that would then feed forecasting. That will be kind of that bucket. The second bucket is optimizing buffers. I talked about a little already, which is how do we think about minimizing some of the buffers which were in place because we had uncertainty, but if we can reduce uncertainty, how do we reduce some of the buffers around it? The third one is about augmenting and automating, right? Augmented reality de-icing, for example, when the de-icing operator has technology support to really know what has he sprayed, what has he not sprayed, or where could she be more efficient and provide some feedback, are systems that are slowly becoming a reality. And then the last one is integrated decision making. And how do we make sure we use the same data across all stakeholders and use graphical situational awareness and decision support tools to really allow people to make better decisions, more data-based decisions, and more coordinated decisions. So a whole bucket of ideas here, and we'll go into some of those details later. So maybe then in closing, next page, please. What could this all mean, right? We talked a little about the big impact of winter operation earlier, and we're never going to get rid of all of it. But a couple of encouraging pointers that we see from current applications. So better prediction and coordination of de-icing platforms could bring a 30% increase in effectiveness of de-icing systems. We've already seen that in practice. Now casting systems create more precise weather forecasts. We've seen 50% reduction in weather-related downtime in some operations from just better forecasting and knowing better how to coordinate. And then lastly, active sensors that monitor the runways for unsafe conditions and allow us to bring down some of these buffers. Again, in some of these cases, we've seen a 3.5% increase in on-time performance, which, as many of you will know, is actually a pretty meaningful number, even though it might look slow. But 3.5%, most airline operating officers would kill for that number improvement. So anyway, that's a quick overview of some of the impacts of winter operation and some of the basics. And I'll hand it over to Vincent to go into some of the around ATM here.
Thanks a lot, Robin. And wow, it's the first time that I actually saw it on paper that during winter you have 4 times the delays than during other seasons. So really impressive. Yeah, next on the line is Vincent from FoxATM.
Yep, thank you, Jan, and thank you, Robin, for that intro. What I'd like to do is show a bit more numbers and what's behind the numbers that Robin highlighted in terms of practicalities. So next one, please. From an ATC perspective, winter operation does 2 things that ATC people really dislike. First, it gets capacity away. It's not only runway capacity, it's also terminal ramp and taxi operation capacity. And it does that in a very unpredictable way. And ATC and traffic management is all about predicting what things will look like in, let's say, 30 minutes to 1 hour to produce the best possible flow of aircraft. As Robin mentioned, aircraft must be sprayed for de-icing, which means you have to apply de-icing fluid over the aircraft in a short time before takeoff. So once the aircraft has been sprayed, which takes time, you cannot have it wait for too long, otherwise you have to restart the spraying and do the whole thing again. The second point is that runways and taxiways must be clear of snow. And I will come into that in a minute, but it's a huge work. It's enormous areas we are talking about here. And the last part is it's not about surface contamination only, it's also that the visibility is much less, which means you can have more go-arounds. You will have pilots taxiing much slower than normally. So all the things you are used to at your airports, all your normal predictions can get quite off because of winter operations. Next one. An important thing also, especially in terms of solution, is that winter is local but has global effects. The winter is not the same thing in Oslo, Geneva, and Dubai. Obviously, if you are in Oslo, you have de-icing operations, snowing, snow clearance operation every year. Every winter, you know, you have a few months of winter operations. Your team is up to speed. You have hardware, you have the ground vehicles you need, you have everything ready and working. And you can invest into making your winter operation work because it certainly makes sense. If you are, let's say, in Geneva or Frankfurt or Paris, you can have 10 years without snow. You can have 10 years without hard winter operations, which means in terms of investment, it's not so easy because the life cycle of the equipment is not unlimited. You have to invest into de-icing fluid and other things. And you have to keep your staff sharp on running winter operations. And if you have a few days of winter a year, and not even every year, it's not so easy. The press cut on the right was from Christmas 2010. We did hit Paris quite hard, and Charles de Gaulle ran out of de-icing fluid. And that they had to cancel flights because of that. And finally, they had to fly in some fluid to be able to restart. So planning for your winter operation in that gray area is not so easy. In some places, you have, for example, agreements with local trucking companies or local farmers to have people being able to come into your airport and do the snow clearing. If you're in Oslo, you don't need that because you have your staff. If you are in the gray area, then you need some special agreements because you cannot afford a full de-icing team being available the whole time. And even if you are in Dubai, you have some effect of winter, not because of snow or winter phenomena locally, but if Western Europe or Northern America is hit by snow conditions and winter ops, it will have an effect on Emirates and all companies flying there, which means you will have ripple effects across the whole network. Local companies will be hit hardly, but global ones will be hit as well because it will have impact on their connecting passengers. It could change the time the peak hour comes. It could mean the peak hour comes differently because a part of the world is in winter operation. And that means there is no standard solution that can be applied to each and every airport. Next one. Even the way airports do de-icing is different from place to place. You can have de-icing at the parking position, so de-icing on stand where the truck comes to the aircraft to be de-iced. Or you have airports which implement centralized de-icing, which means the aircraft taxis out, switches off the engine at a position close to the runway, which is designed for de-icing, where the trucks are waiting and the aircraft gets sprayed there. So already that is a different way of operating, and some airports mix both. Then you have sometimes conditions where each and every aircraft will be de-iced and has to be de-iced. And sometimes you have what we call de-icing on request, which means the surface conditions is not so bad, but the airspace could be a critical aspect. So some aircraft will request de-icing and other will not. And this is also very hard to predict. And quite often in winter operation, the critical resource is not the runway or the taxiway system anymore, but is the de-icing capacity, which is to make the game a bit more complex, not even done by the airport operator, but quite often by third-party companies. So here, technology can help with smarter sequencing algorithms, better capacity management, better prediction, better analytics, but also to help the whole teams to better work together, to connect the people, to give people access to the information they need, and to help people provide the information they have, which is quite critical in this kind of synchronization. Next one. Measuring and managing de-icing is the key here. So the de-icing providers are quite often required to provide data, and this has two natures. They have to provide their de-icing capacity. So they say, okay, on my part, I can de-ice 5, 10, 20 aircraft an hour. But for each and every aircraft, they also need to provide the time where the de-icing can start, so that the aircraft reaches the pad at the correct time, and when the de-icing will be finished, so that we can plan for the next aircraft that has to reach the pad in time as well. And this also helps to synchronize between the de-icing pads and the runways. The question is, how do you provide this information? Is it something that you send on the radio? Is it something that you do per telephone, or do you do manual inputs? Do you record the time of every aircraft? Is it manual? Is it on paper and you get a report at the end of the day? Or do you go into technology and do things like computer vision to detect the de-icing process is started, is stopped? Or do you get signals from the de-icing truck saying when the spray is turned on and turned off? So data is here, and we can certainly use technology here to improve the situation and get better grasp of the de-icing process. Next page. The other factor is keeping the airport and the infrastructure clear of snow and ice and different things. And I know from the outside or from above, an airport can look like a small thing. And the worst thing is that runways look like streets, and you think, okay, de-icing or de-snowing a runway is like a street. This is an illusion. The typical length of a runway at a large international airport is 4 kilometers. This is the length of Central Park in New York. This is more than the width of Manhattan.
All done with isolation as of today. Our symptoms were mild.
Excuse me, there is someone interfering in. I get some extra audio. Okay, let's keep going. So a typical runway length is 4 kilometers. If you drive 60 kilometers an hour, that's 4 minutes. And there is no way you can drive a snowplow at 60 kilometers an hour. So clearing a runway takes, depending on your equipment, on the weather, on the staff available, takes 15 to 30 minutes. And these are let's say the optimal, the planned times. It's not always reality. And there are tons of factors influencing the process and even giving an estimation for these teams, how long it will take to clear the runway, and say to ATC, okay, runway is closed for 15 minutes or for 30 minutes is not easy. It relies a lot on the experience of the people. And here again, if you're in an area with a lot of de-snowing, then your staff gets used to it and they get better at doing estimation. If they do snow clearing operation once or twice a year or every second year, it's much harder for them to provide precise estimations. Next slide, please. What you see here on the left side, to give you an idea of the size of this operation, the picture on the left is in Paris. That's the snow clearing brigade or train. It's 13 trucks and 3 accompanying cars. That's obviously a non-winter day. That's the best situation. That's the easy task. What you see on the right is the reality of Montreal Airport. So you can imagine driving 13 trucks, one behind the other, in this low visibility with whiteout, with snow. That's not an easy thing to do. Next one. Then here again, if you want to bring technology and better automation, you need to know how to measure and manage snow clearing. Weather data archive are available. Every airport has archives of META staffs. You can get archives of the weather forecast. The weather services have a lot of information available in digital form even. Normally, ATC knows when the runway gets closed for clearing and released, so that data exists, it's available. Sometimes it's available in a digital form, sometimes it's in a paper log, so it's not as easy to get it, but you have access to it. And the last option is that you can do ground tracking of the vehicles. Most have a transponder, or sometimes you have a surface radar, so you can know and extract from that data how long the clearing did really take. And how can we use technology here? Same thing, you can go for better communication, have a better communication between the drivers, between the teams, between the team leaders and the ATC. It's certainly possible to use AI for better decision making, especially when we have less of experience by the humans having to make the decision. There are also attempts of doing autonomous vehicles. There was a nice demo by Mercedes where there was one driver in the lead truck and 12 other trucks following automatically. Once again, it was a demo. It was during a nice summer day with nice weather and good visibility. The technology, I think, is not there yet to have that in bad conditions, but it's a step. Robin also mentioned augmented reality, so help the drivers at night or in bad conditions to know where they are, help the de-icing guys to know how to spray where they are and where to spray again. So there are things to do, and I'm sure Chris will bounce on it later on. Next one. In summer or in nice time, we have now in most of Europe what we call ACDM, which is collaborative decision making. And that has shown that technology can help make the best possible use of a limited resource, which was so far most often the runways. Data is here and can be captured, and technology can help improving predictability. So the picture you see on the bottom right is probably something from the past at most airports. We try to have as less queuing as possible, and we use ACDM for that. The challenges of winter are stronger because it's more unpredictable. There is less data and less quality, but data is here and can be captured. So I'm quite sure with the newest technologies that we have now, we certainly can do something to improve weather operations. So this is it for my part.
All right. Thanks, Vincent. And agreed. When you see a runway from the outside, it looks large already, but you still don't get quite the size of it compared to when you actually stand on it. Thanks a lot for your input. So that brings us to the last presenter of the day, Christiaan. Floor is yours.
All right, thanks, Jan-Willem. So yeah, we've heard a lot about challenges and some areas for solutions. And what I'd like to do is dive a little bit deeper and make the link also to some of the things obviously that we're doing at Assaia in winter operations. But before that, I had sort of double feelings talking about winter operations because on one side I know there's many aviation professionals that are almost full-time engaged in winter operations, and they're probably much more, they're definitely much more knowledgeable about this topic than I am. On the other side, in my 8 years at Schiphol, I probably 5 years or so was part of the winter ops team. So I was actually driving these kind of trucks, clearing runways and such. So I think I kind of went back in my own winter ops archive to find some examples. And I think if there's two things that I think I wanted to share solutions on is basically inexperience. Like what we already heard is like this only happens a few times a year for many airports. And the people involved are usually not people doing this every day. And the other thing is the unpredictability. And it has mainly has to do with capacity. And I think it's important to notice that the capacity is a chain. And whatever factor has the lowest capacity is what determines the actual airport capacity. And therefore, the synchronization between all these capacities is extremely important. And Peter, if you can move to the next slide, please. I think in order to be able to synchronize capacities, you need information, both real-time and predictive information, because you want full visibility, even in low visibility conditions. And as many of you know, what we do at Assaia is that we take data from video cameras and use that to generate structured data. So when do events start? When do events end? And then also use that data again to predict when will an event typically end. And this is a picture of our system in operations in a dry and a sunny day. But it's good to know that the system works actually as reliable in days with snow. We've done projects in Finland, in Canada, where we have seen lots of snow. And we also have experience in detecting the start and ending of de-icing operations or anti-icing operations. So that's something that we have experience with and something that we actually know works very well. So let us see in the next few slides how we can take that technology and make use of that in the challenges that we've seen. So first of all, if you have the airport and if it has been snowing, or even worse, if it is still snowing, the gate planner at the airport needs to know, what's my gate capacity? How many inbound flights can I even accommodate based on stand availability, and which stands are only available for parking because they're fully covered in snow, or which ones are actually able to service aircraft and even have passengers on boarding, on and off boarding. So typically, what will be the case is there's actually people driving around reporting back to the tower, back to the gate planner, what's the condition of certain stands. And either there will be a system or even a spreadsheet, keeping track of, what's the color coding. Is it green? Is it yellow? Is it orange? Is it red? What's the position of each stand to be used as an input for stand planning purposes? So the way how we see that, that's labor intensive, therefore cost inefficient, potentially prone to human error. And on top of that, you don't have someone at each stand all the time. So you don't have real-time information. So you're always sort of chasing reality and chasing the actual situation, especially if it's still snowing, because then the condition can actually change on a minute-per-minute basis. So why not, use cameras that you often already have overlooking the apron to see actually what's the snow condition at the stand in order to be able to manage your stand planning in real time based on the real time situation that you have there. Then if you move to the next slide and we look to on-stand de-icing, and especially in relation to departure management, it's interesting to realize de-icing can obviously only start if all the other operations in a turnaround have ended. So first of all, the start of the de-icing on stand depends on all of that. So it's important to know when that will be, not as accurate as possible, obviously. But then, of course, you only want to start de-icing once you know that after you finish de-icing, the aircraft will have a smooth flow over the taxiways to the runway and can directly take off. Because if you take the act of de-icing the aircraft and you spend the de-icing fluid, you spend the resources, you spend the time of the truck and the staff on de-icing the aircraft will be sent off blocks and is then standing in a queue and potentially even over extends its time frame and needs to be de-iced or anti-iced again. That's obviously highly inefficient. So there's one thing where we think, if we can actually see the progress of de-icing, if we can have the system observe, how that's progressing for each departing aircraft, for each on-stand de-icing operation, we can actually predict when is it expected to be ready, so that we actually know per time frame into the future. So let's say in the next 15 to 20 to 30 minutes, which aircraft will be ready for departure, then model these aircraft's path towards the runway. Also, again, preferably based on real-time traffic data, predict the taxi time, know when they are at the runway, so we can calculate backwards when should this de-icing operation start, what's the ideal moment, so that they don't have any queuing and potentially need to be de-iced again. So the real-time information, when can de-icing start and when is it expected to be ready, is key for a smooth departure sequence. I just talked to Nita about when should de-icing start, and the interesting part is if you look at a medium to large sized airport, they will have dozens, if not hundreds, of vehicles specifically for winter operations that are only used a few times a year. So it's highly inefficient in itself, but you need them. However, for the days that you need them, you basically want to make use of them as efficient as possible, so you need as little as possible. Because it's not just buying and owning the equipment, you also have to maintain it, do checks, so that in case there is snow, they're basically ready to go. So again, if you have 50 turnarounds going on and 50 departures planned in the next 1 hour or so, what is your resource planning going to look like? When are you going to dispatch which vehicles, which de-icing vehicles to which aircraft? Again, knowing the ideal moment of when the aircraft is ready to actually start receiving de-icing because all the other ground handling activities have ended is detrimental. And knowing this information in real time and high accuracy will actually allow you to plan de-icing equipment to aircraft in a much more efficient way, and therefore actually be able to run the same operation with much less vehicles. So if we then make the switch towards, next slide, please, Peter, to remote de-icing or the use of de-icing pads, I think it's going to get even more interesting, because here we almost have the full chain of the departure, where the aircraft at some point needs to be pushed back and start taxiing to the de-icing pad, and from there actually taxi again to the runway, and all of this needs to be optimized. So first of all, we want to know what's the capacity at the de-icing pad. So how many spaces, how many simultaneous de-icing operations can be done, how many of those are currently occupied, in what stage are they, how much longer are they predicted to be going on. Again, in order to calculate backwards the ideal time for any other aircraft to be given clearance to actually go to the de-icing pad. And to get this game right is actually, it's pretty hard if you don't have the information. And what you typically see is that a lot of aircrafts will be given the clearance to go off the gate and start taxiing towards the de-icing pad, which then results in a big queue at the de-icing pad before the de-icing pad. And that's all aircraft that are burning CO2, burning fuel, which is bad for the environment, which is a hot topic if we want to build back better after COVID, and which costs money because we're burning kerosene for nothing, which in terms of cost efficiency, I think is also a pretty big topic today. So to get that right, to basically give the clearances from the stand to the de-icing pad at the right moment, but also taking into account the capacity of the de-icing pad into the downward journey towards the runway, again, to make sure that the aircraft doesn't have to stand in line there and run the risk of having to be de-iced again or anti-iced again. So these are, a few of the things where we think, it makes perfect sense to use data analytics and predictions. And it's not just from cameras and aircraft stands, but also, if you want to have information about runway availability, why not use data from vehicles, from snow clearing vehicles, in order to predict how much longer the runway is actually going to be unavailable because they're still cleaning, and when is the time actually that the runway can be put in use again. If we move to the next slide, there's a few other, I think, major innovations there that I wanted to mention because I think they fit exceptionally well into the topic. One is the Snowbot, which is an innovation that has been trialed together with Finavia in Finland. And obviously it holds many advantages, A, because of safety. Again, I was one of the people that actually were operating trucks a few times per year maximum, which means I'm very definitely not optimally qualified to do that. If you have an autonomous system, the chance of human error is just much lower, which increases safety. Therefore, also faster clearing, again, lower operational cost. And another almost side effect, but to me, actually, maybe even the most important factor, that's a smart vehicle by design. So this vehicle by itself will create and generate data on where it is, what it has done, and therefore will actually feed into the entire chain of capacity balancing. And therefore is, I think, a very interesting solution, especially obviously for airports that have a lot of snow clearing going on. So the last thing that I wanted to mention to you, if we can move to the next slide, please, is a solution called SNOCOM. Because we're talking about snow clearing and collecting all this snow, but if you collect all the snow from an airport, which is polluted by all the materials that have been used to prevent the snow from staying on the airport, you will literally have a mountain of snow to take care of. And I've seen this firsthand. You will literally have several aircraft stands of snow, and stories high, and you will have truck operations for days, if not weeks, with digging machines, putting all this snow into trucks and then them driving it off to a post-processing facility. And the funny part is half of snow is actually air and the other half being water. And the SNOCOM solution, I think, is very interesting because it actually processes the snow, takes the air out, makes it much more compact, which means that you need less storage, so it will cost you less capacity. You will need less trucks driving up and down, which again has a safety advantage as well. And therefore, in all of that, it will just have a major impact on the operational cost of winter operations. So another thing that I thought worth mentioning and interesting if you think about innovation and winter operation. That's it for me. Looking forward to any questions you guys have.
All right, thanks, Chris. Very interesting. And I think, for example, one thing that I came across in the past was also that there's always, during winter operations, when there is very low visibility, there is a problem that some pilots that may not be very familiar with the airport go into the wrong direction. And then even if you have some kind of a de-icing lineup, then it gets or the lineup is destroyed basically, and detecting what kind of flight is actually in front of the stand if you have a pet de-icing is, in my opinion, also something that is helping a lot in the future, just to make sure that you are not thinking there will be a 737 coming and then you have a 777 in front of you, which requires a completely different de-icing process. But great, thanks a lot to everyone. So now the floor is open for questions and answers. We have another 15 minutes. And I guess, Chris, coming back to your point, one of the questions is that how hard is it actually to implement these off-block time predictions or the predictions in general into your operational processes at an airport? I understand that these operational processes are often developed or have been developed over many years, and that there needs to be quite some or that there are quite some efforts required to change them.
So the answer, it depends a little bit on the current situation, but I think what is a very good thing and what makes a transition to the use of these kind of technologies in many cases relatively easy is that a lot of airports have already adopted ACDM best practices, not only in Europe, but also in the US and in Asia, we see it quite a lot. And the interesting part is that often there is a component like a target off-block time, which is currently an estimation that the ground handler gives when he thinks he's going to be ready with the aircraft. It already exists, and we don't want to change everything around that. We just want to swap these two things. And it's even interesting that we don't even want to make the target off-block time, for example, disappear, because there's a lot of interesting information in this target off-block time as an ingredient into the predictor. So we actually use the TOPT, but not as the final product, but as an ingredient to create a prediction that is then just fed into the process as it's already there. So obviously that's the easiest way, and for airports that are not yet using these kind of concepts, there's a ton of best practices from the airports that are doing that. So in many cases it can be very smooth and seamless, and in some cases required, but there's a good approach.
Thanks a lot, Chris. One more question for Vincent. According or from, in your opinion, what is kind of the required planning horizon for the departure management process? So for example, for runway assignment and for off-block times and so on and so forth.
Thanks, Jan. That's an interesting question indeed. That's all the point about planning. When you are at the ATC position and you have to decide, for example, to which runway an aircraft has to go, it's not something you can do 2 minutes before off-block or 5 minutes before off-block, because the pilot has to be informed. You have to plan a taxi route. You have to integrate the capacity for that aircraft taxiing on certain taxiways. So if the de-snowing people tell you, oh, that runway will be closed in 5 minutes, it does not really help you, because you have aircraft that are already taxiing to that runway, and you have aircraft that are already knowing they will go to that runway. And same thing, if your capacity and the structure you have available changes all the time, you cannot really plan. So ideally, I would say, to come back to a number, 30 to 45 minutes ahead, it's a good way. And that's roughly what we have in Europe in ACDM airports. So you do decision and you do planning 40 to 30 minutes ahead of the TOBT. Otherwise, you're not planning, you are running after reality.
All right. Cool. Thanks a lot, Vincent. I guess that answers the question. Is there any more, or are there any more questions from the floor? Otherwise, I thank our three panelists for their time today, for their insights. I thought it was a very, oh, sorry. There is actually one. Oh yeah, that, I guess, Chris, that goes into your direction. Are there any thoughts from the panel in general, but I guess, Chris, on how to get the cameras placed in view of de-ice pads? So this is for remote de-icing on de-ice pads. Very good question.
Yeah, we've obviously have to answer this question, not just for de-icing pads, but in general, also for remote stands. And typically at airports, in almost in every case so far, there is some sort of infrastructure present, either buildings or light masts that are good locations to put cameras. So it depends. We'd have to take a look. But I would expect us to find something like a light mast or something similar. In a worst case situation, a pole could be placed to mount a camera into. But it's also good to know sometimes connectivity in terms of network infrastructure at remote sites might be more difficult. There are also solutions from our side where we offer 4G cameras or cameras tied to edge processing units that have 4G connectivity in order to also connect cameras that are not directly at a terminal building. So there's some pretty good solutions for that.
Yep.
Jan, if you don't mind, I'd like to complement on that.
Sure.
Actually, most airports have hundreds, if not thousands, of cameras already in place, and some can provide good quality already.
That's actually true, and most of the de-icing pads that I have seen in my life, I have to say, it's not like hundreds or dozens, but at least the ones I have seen at least have, as Chris said, some kind of external structure, like often lamp masts in order to lit the area, because winter operations appear in winter where most of the day it's rather dark. And so there's normally the infrastructure available that is required in order to attach some kind of cameras. And then there's also, as Chris said, the possibility to have completely independent cameras from any cabling or networking in order to work on there. There's one more question. Does anyone see a need for FLIR, FLIR, or other enhanced vision in order to apply the video analytics?
I'm not sure. I'm not sure what exactly FLIR means. Do any of the other panelists can help me out?
FLIR would be infrared, right? So it would be not just visual, but infrared visioning. And I guess maybe expand the question to LiDAR as well, right? So if we forget about just visual cameras as we use for kind of human view and think about machine vision, are some of those other sensors, whether it's infrared or other imaging systems, going to be needed, I think is where the question comes from.
Yeah, nighttime and low visibility considerations.
So I can only draw on our current experience where we have not seen the need for any other than RGB sensor, so just regular camera, which worked pretty well for these cases. So, maybe if we go down this path and get into more specifics, potentially, but I don't think so right now.
I could comment something on that as well. Infrared at an airport is not always easy. I've been involved in a project using these technologies lately. And one of the issues you have is that the ramps are usually heavily lit. And if your camera is on the terminal building and has to go via infrared through that heavily lit ramp, it's not as good as infrared just in normal night.
All right.
Interesting.
We are now getting some more questions, and I think there is one question that I particularly like because it's a little bit of it's a tricky question. So thanks, Jose Sanz Dodero. He says it has been a very interesting panel, but don't you think that we need to accept that winter operation is basically always going to be a critical process, and that there will be delays and cancellations, and if it will not be more useful to cancel flights in advance in order to avoid passenger problems in the terminal?
Maybe I'll start on that one. I think it's an excellent question, right? And I think, as I said earlier, we have to accept that there's going to be some implications from weather, right? Winter weather will reduce runway capacity, will reduce airport capacity, will require additional processes, and as a result, capacity will go down overall. And if we have busy airports that are scheduled to capacity, as we do in the US, we schedule them even tighter than in Europe, there will be delays when we run into the reduced capacity. Now, the question is, how much does this capacity have to be reduced, and how much do we accept it? And then on the other hand, how early can we be in finding mitigating measures? So on the first question, how much does the capacity have to be reduced? I think we've discussed a few cases here now where we are reducing capacity by too much, and we're creating some gaps that could be filled, either because we have poor planning or poor coordination, or we just don't deal well with the uncertainty. And so deploying some methodologies out there and solutions to just take advantage of all the available capacity, I think will help. And so that should reduce delays to some degree. And then I think to the other point, which is an excellent one, which is if we get better forecasting and better prediction and can be better in proactively canceling flights, consolidating flights, rescheduling flights, that'll minimize the customer impact as well. But fundamentally, we're dealing with an uncertainty here, right? Because even the best AI at times is not going to be able to truly predict, every snowstorm coming through, every micro environment like an airport and the impact it will have. So there's always going to be some uncertainty we'll have to buffer for, and some surprises we'll have. But I think with more technology, we can minimize those impacts. And I think an interesting follow-up study here would be to really understand how much of the reduced capacity can we gain back with better systems, and how much can we really predict and therefore proactively plan if we deploy all these tools. I don't have a great number of that, and not even a good gut feel, but I would think the number is material.
Thanks, Robin. I think also it's a very good question, because in the end we will never get to a zero delay world. So there is always a cost-benefit analysis to be done. Maybe there are now two more questions, but I think we only have time for one more. So Sergio, we will get back to you about your questions. Sorry for not being able to answer today, but we got two questions that are kind of circling around weather, and so I would like to combine these two. So from Wahid Hesare, the question is, predicting weather accurately is key in the whole process, which is definitely a right statement. What is the state of the art of weather prediction at airports? And that goes in line with a question from an anonymous visitor. Perhaps the root cause analysis of the overall problem would bring us back to the issue of weather itself. Any thoughts on weather modification efforts such as cloud seeding, etc., to remove one of the elements that are required to make snow? That's definitely an interesting idea. And I think if I remember correctly, actually in Russia, they use some of these methods in order to have nice weather when there are important events. But I'll give it back to the floor. I think that the basic question is like, what is state of the art in weather prediction and weather detection, so to say, and are there possibilities to actually influence the weather on a very local area?
Okay, I can give a try at that and then hand over to Robin. First, the issue is that we are really talking about very, very local activity here. An airport on one side is large, but it's also not that large. So if you have a large snow event on your airport, or let's say 5 kilometers away, which in terms of weather prediction is very small, it makes a big difference for you. And the second thing on cloud seeding, and so that's something we use in some parts of Switzerland to, in another context, to prevent thunderstorms. Because if the water comes down brutally in a thunderstorm, it can create damage. And with cloud seeding, you can try to, and insisting on trying to, have it coming down earlier and in a more controlled way. But with snow, the problem is that it will come down anywhere and bring you into trouble. So I'm not seeing a lot of chances with cloud seeding here, at least with what we are doing now, but maybe Robin has different views on that.
Yeah, I'm not a meteorologist, and I don't have a good view of how we can manipulate the weather, especially when we're talking about large weather when it's snowstorms. I think that seems more difficult. But I think, look, on the first point around the state of the art of weather forecast, I think we've made some progress by leveraging data, but the granularity is still not quite there, right? Even at a local airport, you're depending on radars that might sit quite a bit away for weather information, and you're depending on sensors that might not update in real time, and then you might not have a local processing unit. And there's a couple of big players who process the data but do it at a larger scale. I think there's a few startups that are promising in this space that are focused on micro weather, and have seen some airlines invest in some of these startups because they think there's a real use case here to deal with winter operations for one. And so I do think in the next couple of years, we will see more, call it pop-up sensors show up around cities and around airport facilities to provide additional data. And we'll see some of the micro weather players starting to predict much more precise, much more granular, both in geography and in timing of what's going to happen with these events. But we're not quite there yet, but the first trials look quite encouraging.
Great, thanks, Robin. That's good input, and I think, yeah, cutting or getting rid of the problem at the source, at least understanding the problem better at the source, is probably one of the key things that we have to look at when we speak about winter operations first. All right, having a look at the time, again, we will get back to the remaining open question. Thanks for asking it. Here's an overview how you can contact our panelists today. I would like to thank Robin and Vincent and Christiaan very much for the time and insights today. It's been a pleasure. I thank every attendee today for their time. I hope you learned something new, and I hope it was worthwhile your time. And next month, we will not have our regular Reboot Aviation webinar, but we will do a virtual panel discussion where we have 6 or 8 of our Reboot Aviation partners attending. And we will also open the floor for all attendees to ask questions and to discuss. And we will basically have a 1.5-hour session and look back into on 2020 and see if it was simply an annus horribilis that really hurt the aviation industry, or if there maybe also was some kind of a opportunity for the aviation industry to kind of speed up the innovation process in order to become more efficient and more resilient to these outside shocks. And with that, I'll leave you to it. Thanks again, and I'm looking forward to seeing you again next time.
Thanks, everyone.
Thank you. Bye-bye.